Hello, CVPR 2022. I'm gonna present our work AdaMixer, a fast converging query-based object detector. Recently proposed DETR-like or query-based object detectors become a newly popular detection paradigm. It uses queries to directly represent objects by apply cross-attention-like operators between queries and image features several times. While exploring a new approach to model object detection, these methods also face several challenges, like slow convergency, complicated architectures, computation costs, and poor small object detections. In this paper, we argue that the query decoding should be adaptive rather than static regarding input images, since such detectors are required to cast limited queries to potential objects with variations across different images. Our work improved the query decoding adaptability in two aspects, positional 1 and content 1, for translation and scale variance and appearance variance correspondingly. To begin with, we focus on the cross-attention operator and regard it as two steps: sample features first and decode sampled features then. Here two ingredients make our cross-attention variant, respectively, adaptive 3D feature sampling for sampling, and adaptive mixing for decoding. These two ingredients are also designed for positional adaptability and content adaptability. The adaptive 3D feature sampling procedure gathers multi-scale feature maps directly from the backbone network to construct a unified 3D feature space, and defines an interpolation method on it. The 3D in its name is just 2 plus 1D, 2D for x-y axis, and 1D for scale axis. A query generates a set of offsets adaptively and sample features according to these offsets. The adaptive 3D feature sampling enables a query to learn where to look given what it had seen at previous stages, and the adaptability to the spatial locations and scales is enhanced. Moreover, this process does not require explicit pyramid networks but involves multi-scale feature interaction with following adaptive mixing. Okay, adaptive mixing is the second ingredient to make our cross-attention for a query decoding sampled features. It is an adaptive variant of recent MLP mixer. Inside it, channel mixing and spatial mixing are applied to the sampled features, where kernel parameters are adaptively generated by the query itself. Adaptive mixing enables a query to learn what expected to see and what to do after, given what it had perceived at previous stages. And then the adaptability to the object content is enhanced. The query decoder in AdaMixer generally follows the multi-stage DTR decoder, including the self-attention, the cross-attention variant and FFN layers sequentially, where the cross-attention variant is just adaptive 3D feature sampling plus adaptive mixing. Eventually, the overall AdaMixer detector consists up of just simply a backbone and the query decoder introduced before, with no attentional encoders or explicit FPNs required. Experiments validate the leading performance of AdaMixer with fast convergency, training sample efficiency, and satisfying small object detections when 1x training schedule are applied. AdaMixer outperforms most of well-established 1 or 2 stage detectors and also outperforms query-based detectors by a large margin with limited training budgets. With the longer schedule and data augmentation aligned to DTR, AdaMixer still reaches the leading performance when compared with other query-based detectors. Moreover, the theoretical flops of AdaMixer are lower than other query-based ones in the table, and the actual inference FPS is also satisfying. We also plot the fast convergency of AdaMixer and other typical query-based detectors. There are some key ablations and observations: the positional adaptability for decoding sampling locations and the content adaptability for decoding sampled features are nearly equally important. First, channel mixing and then spatial mixing makes a better adaptive mixing design. The adaptive 3D sampling outperforms counterparts. We also perform some visualizations. Here are an input image and its AdaMixer detection results. We can investigate these sampling locations by visualizing them across stages. To recap, AdaMixer is a query-based object detector with a simple backbone and decoder-only architecture. It enjoys fast convergency, leading performance, lower computational costs, and small object detections. The code is available at GitHub. You can scan QR code to get it. This is the end of the presentation. Thank you.